Hello everyone, and welcome to STEAM Team Tuesdays, where we will be exploring exciting experiments and adventurous activities using many items you can find in your home. My name is Kristen, and for the next 4 weeks together, we're going to be exploring a theme that is both scientific and delicious. Candy science! And for the first episode today, we'll be working on our very own at-home experiment called the Dissolving Pumpkins Experiment, using no, not these kind of pumpkins. These kind of pumpkins. Now, before we begin, has anyone used the scientific method before? Well, this experiment will help us to make predictions, test them, and then record our results using the steps of the scientific method, just like a professional researcher or scientist would do. So if that sounds good to you, let's begin by seeing what we will need. For this activity, you will need a package of candy pumpkins. Specifically, you'll need 4 candies, and you could also use candy corn or any other type of soft, sugar-based, dissolvable candies. This is a great way to use up some leftover Halloween candy. In addition, 4 cups. I'm using these red plastic cups here. And then about a 1/3 cup of cold water, or enough water to cover your candy, about a 1/3 cup of warm water, a 1/3 cup of vinegar. I'm using white vinegar, but feel free to use any vinegar that you have available to you in your pantry, and about a 1/3 cup of cooking oil. Today I'm using olive oil, but again, feel free to use canola oil, vegetable oil, or any other cooking oil that is liquid at room temperature. Finally, you will need a piece of paper to set up your results chart, a pen, and optionally, a Sharpie. As you can see here, I use the Sharpie to write each of the names of the liquids, warm water, cold water, vinegar, and oil, on the sides of the red cups. That way, I don't mix up which liquids are in which cups, which will become important once we are analyzing our data at the end of the experiment. Now we move on to the steps. Step 1 in the scientific method is to ask a question. And today our question is, what will happen to our candies when they are dropped into each of the different liquids? For example, will each of them dissolve? Will some liquids dissolve the candies better or faster than the other liquids? Let's set up our results chart to start. You can write the experiment and your name at the top, and then what I've done is write each of the liquids across the top: cold water, warm water, vinegar, and oil. Below it, there are boxes to place our pumpkins in once they're done, and below that, room to write our results. You can write any predictions that you have on the back of your sheet of paper. Step 2 is doing some background research. You may want to take a look in a book or have an adult help you do an internet search to find some information about what we'll be talking about today. So here's what I found. A solute is a substance that gets dissolved, and a solvent is a substance that dissolves the solute. So in our case, the solute is going to be the candy, or we could also say that it's the sugar, since our candies are mostly made up of sugar and coloring. Now, the solvent will be our 4 different liquids. So we have 4 different solvents today. Different solvents will be able to dissolve the solutes perhaps better than others, based on how much the molecules in the solute attract to those in the solvent. For example, as with sugar and water, those molecules attract to each other quite well, while the molecules in vinegar and oil do not attract quite as well with the sugar molecules, or not even at all. Another thing I found is that if a solvent is heated or warmed up, like the warm water that we have in our experiment, then it may be able to dissolve the solute more quickly. Step 3, based on what we've just learned, it's time to construct a hypothesis. And a hypothesis basically means a prediction. So we're going to make our predictions and write them down. Here's a few questions to help get you started. What do you think will happen to the candy that's been sitting for a few minutes in the warm water versus the cold water? Which one will dissolve the candy faster? And what might happen to the candy that's in the vinegar? What about the oil? Write down your predictions. Now that we're prepared, let's begin. Step 4 is to test our hypotheses. Now, if you haven't already, it's time to fill the cups with the 4 different liquids. Here I have the warm water and cold water in the left and right top cups, and then the white vinegar and the olive oil in the bottom left and right cups. Now take your candies and place 1 candy into each of the cups, making sure that each of the candies is fully submerged in the liquid. Now to wait and observe for 10 minutes. You can set yourself a timer, and if you'd like to, now's a great time to have a snack or doodle a picture while you're waiting for your candies to be ready. For the sake of this video, we're going to fast forward. Step 5, it's time to analyze our data. So by now, it's been 10 minutes that our candies are sitting in the liquids or solvents, and the candy is our data. So let's get our results chart. Place a piece of paper towel or cardboard or something underneath just to catch any drips, and then carefully remove each of the candies and place them in the box that you've created for them on your chart. Now, what do you see? What does your candy look like? Another great place to look for clues is in the cups themselves, in the liquids. So do any of the liquids or solvents look like they have more dissolved candy or coloring in them? Now write your conclusions on your chart underneath each piece of candy. For me, the most dissolved piece of candy was the candy that was in the warm water, followed by the candy that's in the cold water. And actually, for me, the vinegar and the cold water, they dissolved the candies pretty much equally. But the oil didn't seem to dissolve or change the candy very much at all. Finally, step 6. It's time to report our results. So tell somebody, tell a friend or a family member what your findings were. Did the candies dissolve how you had predicted? Or was it different? Either way, we've learned something. So I hope you enjoyed this experiment. And for a remix on this experiment, use any leftover candies that you might have with some different solvents or beverages that you might find in your fridge or your pantry, using the same technique. First, do some research, make your predictions, test them, and record your results. So here's some beverages that you might want to try. How about milk, apple juice, orange juice, tea, coffee, or soda? You could also try using different types of candies in the same solvents that we used in this experiment and see if you get different results. And here's something to think about. Every time you dissolve a drink powder, such as when making lemonade, iced tea, or hot chocolate, you're dissolving sugar crystals into water to create a new beverage. So this is super similar to what we did today in our experiment, dissolving the candies in the cold or warm water. and it's also very tasty. So mix up one of these beverages today for a sweet treat. So let's review. Today we practiced the steps of the scientific method using some festive candies. Plus, we observed how sugar that the candies are made up of can dissolve differently in different liquids and different temperatures. Up next Tuesday, we'll be learning how to make our own rock candy, which is actually building on our knowledge of solutes and solvents. This is an experiment with a result that you can eat, so you don't want to miss this one. I will see you then, S.T.E.A.M team. Bye!